Alright guys, welcome back. This is Professor Hank. In this video we're going to talk about another feature from C++11 that you might have forgotten about, or maybe you never learned about in the first place, and that feature is going to be strongly typed enums, right? So strongly typed enums, and these were a response to some of the problems that the old style enums had in previous versions of C++, right? So, what are enums? They're a way of creating integer constants that have names, right? So named constants, and there were a few issues with them, right? One of the issues was that the enumerators could be converted to an int. Okay, that might have been bad. They were unscoped, so it was impossible to have enumerators that have the same name. So enumerator is another name for integer constants. Another problem was that the data type of the values in the enumerators couldn't be specified, and so the strongly typed enums dealt with all of these issues. Okay, and so they also allowed for there to be some type checking at compile time. So let's take a look at what we're talking about here, and I'll switch on over to Visual Studio.
All right, so let me show you what I'm talking about here. So if you've got, maybe a old style enum, call it foo, and I'll put in here 1, 2, 3 different enumerators in there, and then we'll have another old style enum called bar, and then I'll put maybe a couple different enumerators in there. Okay, so you're going to see first off that we've got a clash with the name, right? I mean, when you try to assign 1 to F here, which one are you trying to assign? Okay, so that's one issue. Another issue is, maybe semantic. If you wanted to compare, say a foo against a bar, right? The old style enums allow you to do that, and maybe you want to be able to do that. Maybe you don't. I mean, what does it mean to compare a foo against a bar? Does this make sense? Maybe it does. Maybe it doesn't. Another issue that these old style enums had was that you could assign to integer variables the enum, the enumerated data types, or the enumerators. Again, maybe you want to be able to do that, maybe you don't, but you have an implicit conversion from one type to another there, which could have some unintended consequences. So these are all potential problems that you had with the old style enums. Now, with C++11, they came along and tried to address some of these. Okay, by adding this keyword class in front, suddenly things change. Okay, for one, you can now have two different enumerators, right? Or I guess you could say an enumerator with the same name in two different enums. Okay, so now I can sit here and I can say f equals 1, right? If I specify which enum I'm talking about, which enumerator I'm talking about, by using the name of the enum and that scope resolution operator. Now, if I try to do a bar here, well, now I'm not going to be able to, right? Because I'm going to have a problem of trying to assign one type to another without any way to convert it, right? There's no type conversion that's going to happen there. So I'm protected there. But now also, if I want to do a comparison, I'm now locked in to doing a comparison of correct way, I guess you could say, right, of one type against another. Because for one thing, I can't do this anymore because 4 is undefined, because its scope is within the enum bar. 1 is undefined because its scope is in the enum foo or within the enum bar, depending on which one you're talking about. So if I try to compare the foo one against the bar 4, I'm going to get another error because these are two different types of data now. Okay, so that's going to force me to do comparisons of like types. So maybe I'm trying to compare bar 1 versus bar 4. Okay, well that's fine. Another thing is that you don't have that implicit conversion anymore of a enumerated type to a primitive type, int, right? Now you got a message here that says, hey, you can't do this. You could, but you'll have to instead cast it, right? So you have to explicitly say, this is something that I want to do. You're not going to do it by accident. And you could even compare a bar versus a foo if you do that casting as well. So foo 1, is that equal to static cast int bar 1, for example. Okay. If so, then high. Right. So the point here is that you're not going to be comparing dissimilar types against each other by accident. You have to go through and you have to take this extra step of doing this casting. When you want to do some comparison, when you want to do assignment, and that sort of thing. So these are improvements in terms of overall safety, and it's actually best practice now in C++ to use these strongly typed enums. Another thing you can do is you can specify which integral type you want to use to represent these enumerators. So you could save some memory. For example, instead of using a 4-byte integer, you could use a 1-byte character, or maybe a short integer if you want, going down from 4 bytes to 2 bytes, and so on. So you have some additional features here that you didn't have with the old style enumerated types. So there you go. Hopefully you found that useful. As always, if you're a student of mine and you have any questions, please feel free to shoot me an email. Stop on my office hours. And for everybody else, if you thought the video was helpful, please consider giving it a thumbs up. If you thought the video sucked, please consider giving it a thumbs down as well. And thank you for your support. Consider subscribing, consider joining as a member, consider supporting the channel in different ways for additional perks. Thanks for watching, and we'll catch you next time.